Hey guys, Saion Gupta here, founder of 10x Coder Kids and an official Guinness record holder for the youngest computer programmer in the world. And today we are going to be seeing this very fun Python exercise which will probably get you too. So without any delay, let's get started. So over here, as you can see, we have a function x, right? And basically we are taking in two parameters m and 2, and 2 is basically having a default value of empty list, right? So 2 is having a default value of empty list. So if 2 has not been passed, then its default value will be empty list, right? Then we are saying 2 dot append m, right? So whatever m is passed, we are appending that to 2, right? And then we are returning 2, right? So we are returning 2. Next, what we are doing, we are calling we are creating a variable L and calling x and passing it 12. So basically it will add 12 to the 2 list and then it will return us that 2 list, right? And we'll get it in L. Next, we are creating a variable n, right? We are calling x, right, and passing it 42, right? So basically then it will add 42 to the 2 list, right? So the 2 list, it's adding 42 to that 2 list, and in both the cases we are not giving any value for the 2 list. We are letting it select the default value, that is the empty list, right? So we are letting the function select the default value, right? Next, we are printing L and then we are printing N. So after looking at this code, you look at it for half an hour and all, and if you don't run it, you'll see most probably you'll expect that the answer is a list with 12 and a list with 42. Because if you think right now, what will happen? 12 will go in, 2 is not being passed, so it's an empty list. Empty list will be taken. To the empty list we'll append 12, right? And then we'll return the list that contains 12. Next, when we call x with 42, it will basically again take 2 to be an empty list, right? It will append 42 to that empty list and basically it will return a list with the number 42. So when we print L, it will show a list with 12, and when we print N, it will give us a list with 42 in it. But let's see what we get after running this code. Oh my god, we are getting two lists in which we have 12, 42, 12, 42. But how? So the way we think default parameters work, actually they don't work that way. We are thinking that on every function call it is taking this list, right, and taking it as the value of 2, this list that we have given over here. But that's not the case. First of all, that we have all learned, or maybe if you haven't, then I am going to tell you. The first thing is that whatever default parameter is there, right? So whatever default parameter is there, that if like for example the value for 2 is not being passed in the function call, so it will pick up the default parameter and it will put it over here in the function call, right? So it manually puts the default value in the function call, right? So it manually puts the default value inside the function call. This the program does, right? Second of all, let's just understand what is happening. When we have a primitive data type, mostly with default values, we have mostly primitive data types, so we don't get to see this. But actually for default values, what happens is that there's a memory location allocated to the default value. So 2 is allocated the memory location, for example n, right? Or let's say b. So b is the memory location for this 2 default value, and at first it will be set to empty list, right? So in b we have an empty list, right? Now when we call x12, what will happen? We are not giving any value for the default parameter 2 over here. So it will pick up the value from the memory location B. So from B it will pick up the default value, that is the empty list. It will put it over here and then it will call the function. So after that what will happen, it's appending M, that is 12, to the list, right, and it's returning 2. Now what is happening, we are as this is a list, right, we are directly changing the list in its memory location. We are not actually changing the memory location of the list, we are appending to the list, meaning, sorry about that, we are appending to the list, meaning we are changing the list in its memory location itself. So in B memory location only, the list is now changed to a list with the number 12, right? So the list that was there in B, the empty list, that has now been changed to a list with the number 12. Next, when we call X and pass 42, then what will happen? It sees that there is no value given for 2, so it will go to B, that is the memory location for the default parameter. It will pick up the value that was there in B, that is a list with 12, right? And then it will append M to it. So now it will append 42 to this list, right? So it is appending 42 over here also, right? So mostly it's not suggested to use like these mutable data types in as default parameters, but when we are using this, we get some unexpected results, guys. So over here 42 is appended to the list, and also B has been changed to 12, 42. Now when we print L, we get 12, 42, because L was also pointing to the same memory location B, and N was also pointing to the same memory location B. So both have 12 and 42 in it. So both are lists that have 12 and 42. So if we show the type of L, right? So if we show the type of L and type of N, then we'll get the same that memory location that we see. Oh, okay. So mostly in some editors, it also gives us the memory location that where the list is stored. Over here it's not giving, but N and L are both pointing to the same memory location, right? That over here we have taken as B. So B is the memory location for our default parameter, right? So if we had a primitive like 10 over here, right, let's just comment this code, right, and if we have a primitive like 10, right, then what will happen, then basically same thing will happen. It will assign a memory location for the default parameter in which there will be 10, right? But when there are primitive data types as default parameters, then we don't see this, because when we are changing the data type, like we are saying 2 equals to 20, then it is changing the memory location of that also, right? So but when we are working with lists, it's directly changing the list without affecting its memory location. But when we have primitives and when we try to change primitive values, then basically the value and the memory location both change. So we don't see this behavior in lists, in primitive data types, but in lists of dictionaries we will see this behavior. Now what if we pass in like a list, for example a list with 5? What will happen then? So we are giving value to 2, right? Now this list that has 5 in it, its memory location is something else only, right? So its memory location is not B. Let's say its memory location is C, right? So C has the list with number 5. So when we are passing this to 2, right, it's changing the memory location, right? So now this B memory location won't be affected, right, as we are not working with that memory location. We are working with the C memory location in which there's the list with the number 5 in it. then 12 will be appended to it, right? So we will have a 5 comma 12, right? And then 2 will be returned, right? So in L we'll have 5 comma 12. And note that the default parameter, the basically the B memory location, that is the memory location of the default parameter, that is still empty in this process. Next, when we call X with 42, right, and we leave this list empty, right? So when we leave this list empty and we call X 42, right? So we leave this spot empty, right? Then what will happen? It will do the same thing. It will go to the B memory location. It will pick up whatever was there in the B memory location, that is the empty list. It will pass that value that is there in the B memory location. Then it will add to that list that we passed, right? And B memory location will also be affected by that. So 42 will be added into 2, meaning 42 will be added into the B memory location, and then the value that is there in the B memory location is being returned, and that is being saved in N, right? So in N we will have a list with the number 42 in it. So when we run this program, we will basically have 5 comma 12, and then we'll have a list with 42. So we got 5 comma 12, and then we have a list with 42. And if we like don't give 5 over here and give 5 just over here, then what will happen? Then what will happen, it will first basically pass 12 over here, right? And 2 is empty right now, right? So in the B memory location we have an empty list, so it will pick up the value from the B memory location, it will pass it over here, right? And basically then it will add to it, right? So it will add 12 to it, right? So 12 will be added to it, 12 will be added to the B memory location also, and then 2 will be returned. So L basically has a list with 12 in it. Next, when we call basically X with 42 and 5 inside of it, then basically we have B already with 12, but now B's this is not the time for B to work, it's actually C memory location. Now the we are working with the C memory location, we are not at all working with the B memory location only. So we over here we are appending M to the C memory location, so it will be 5 comma 42 over here, and the B memory location will be unaffected, right? And basically in N we will have a list with 5 comma 42. So when we print L, we'll get list with 12, and when we print N, we'll have a list with 5 comma 42, right? And when we have 5 in both the cases, then what will happen? Then this is this is a different memory location, this is a different memory location, so we will also have a D memory location that will be there, right? And in that we will have 5, right? So D memory location is for this, C memory location is for this, and B memory location is for this. Now B memory location is empty. When we call this, right, then basically we are working with the C memory location, we are not at all touching the B memory location, and 12 is being added to the list that has 5 in it, right? So and after that we'll get 5 comma 12, and over here we'll get 5 comma 42, right? So B memory location remains unaffected, the C memory location is affected, the D memory location is affected, right? But these memory locations are basically garbage collected, right? So these values are garbage collected afterwards, right? As they are not required, right? So because we just passed in 5 like this, we are not saving it anywhere, right? So we are not saving this empty list 5 anywhere, right? So B and C and D memory location are garbage collected later on, right? So we cannot see what is there in the C and D memory location. But one important concept that we have basically seen, right, and learned about is that when we have a mutable data type inside like as a default parameter, then we'll get some unexpected results. And also there's this one memory location allocated to the default parameter that will from that memory location, the default parameter will always be picked up and will be inserted over here, right? So from that default parameters memory location, the value of the default parameter will be picked up and then it will be put in over here, right? Where you have given nothing, it will be put in over here, right? So this was it, guys. I hope you understood. If you have any further doubts, please comment down below, and I hope you like the video. Thanks.